it's not like you'll use Huff to write every single one of your contracts, right? That would just be, masochism. It would be terrible, right? But at the same time, like if you learn Huff, Yule is suddenly going to become easy. And if you learn Yule, Solidity is suddenly going to become easy. You can start to really appreciate the tech stack on which these higher level languages are built on. So you have like that classic idiom of like, you should learn Python, you should learn C++, you should learn C, and then you should learn assembly, right? And so when you're dealing with the Ethereum virtual machine, I would say that stack is kind of like learning how to write raw bytecode, then learning how to write some language like Huff or ETK, then learning how to write Yule, and then learning how to write Solidity. And it doesn't necessarily need to be done in that order, but the amount of appreciation that you can get for some of the more higher level features that people have implemented with these languages from going to the low level is just incredible.
Hello and welcome to another episode of the Devs Do Something podcast. Today's guest is Vex, a software engineer, smart contract developer, and major contributor to Huff, a low-level assembly language for the Ethereum Virtual machine. Vex knows a ton about the EVM at the low level, and we go deep into why Huff is a great language to learn for building incredibly gas-efficient contracts. Huff is also being used more and more as an educational tool, as it allows you to build programs that are, as Josh says, equivalent to bare metal Ethereum. If you're interested in low-level smart contract languages and developing a deeper understanding of how the EVM works, you'll love this episode. I hope you enjoy. All right, so we are here today with Vex. Vex, thank you for being here, man.
Yeah, no problem at all. I appreciate you guys having me on.
Fantastic. So we're going to dive into all things Huff and more today. But before we do that, I would love to just understand a little bit about your background and how you got involved in this space.
Yeah, of course. So I am a senior in college at the moment. I am graduating in December. I've been writing code since I was about 10 or 11. I actually kind of started out with some like video game modding and stuff like that. And then for like probably about 5 or 6 years, I was like really deep into just like front end stuff, like creating like analytics dashboards and stuff like that. And then once I actually got into college, I got really fascinated with kind of like more back end engineering. So I got kind of C++ pilled for a while, and then I started working with some x86 stuff. And then one of my really good friends and my old roommate introduced me to Ethereum probably about 2 years ago. And just the concept of being able to publish immutable code and create these things called smart contracts just like captivated me immediately. So I basically kind of like dropped everything that I was working on at that point and just kind of started digging around various resources that were around on learning Solidity and figuring out just kind of how to like interact with smart contracts. One of my first projects was an analytics dashboard for an old DAO that I used to contribute towards. And then over the like months, I just got more and more interested into doing like more heavy contract development. And so I contributed towards that DAO for a while. I interned at a fairly popular cryptocurrency company. And then that kind of brings us to this year where I kind of just randomly tweeted out that I really wanted to rewrite the Huff compiler in Rust because I was learning Rust at the time and I didn't really have anything great to put that skill towards. So I had like tried to rewrite one of my MEV bots in Rust, and then I was just looking for a more advanced project to work on. And so Jet from Rari, and now he's working at Pentagon, reached out to me and said that Andreas and a couple other people had already started working on the Rust compiler. And so I was completely down to work on it and just got nerd sniped into it. And that's kind of been my main project since then. We've done a couple like cool side projects. Like I wrote the Huff SNARK verifier earlier, and we've just been using the language a lot since then. But yeah, I mean, just a pretty incredible journey, and I've loved working in the space so far.
I love that. So you mentioned in there Rust to Huff, right? You kind of made that You made that. Maybe you didn't make that journey like consecutively, but what got you excited about Huff and low level languages?
Yeah, so I think that like Huff specifically is a really unique programming language in the space. So just a little bit of a history lesson on Huff. We actually weren't the people that created Huff. It was Zach Williamson of Aztec. And he referred to it as like a piece of runoff that oozed out of the primordial slop while making wire strudel, which is like an incredible library. Everybody should go check that out. It's basically like the most gas efficient scalar multiplication library on Ethereum, right? And so there's some just crazy dark magic inside of there. It's an incredible code base. But after reading that and like kind of like learning more about just the possibilities that you have whenever you can like fully manipulate the stack and you don't have some of the higher level language features that things like Yule have. So like Yule feels like a very low level language, but it has like a free memory pointer and for loops and things that whenever you start to write Huff, you start to really appreciate, you know? So that aspect of stripping those things away, it kind of reminded me of when I was diving into x86 and just going back to EVM level assembly was just a really cool thing. And it kind of filled that gap for me where Yule still does a lot of things for you. It will schedule the stack. It'll basically, you have the free memory pointer, like I mentioned, and all of those things are really useful features that you start to realize whenever you don't have them are pretty important. And so it was almost like that interface to like really properly learn more about the EVM on top of like diving into Geth and figuring out all of that.
Nice. Yeah, I know, Josh, you have lots of opinions on this as well, the comparisons between Huff and Yule. So I want you to comment on that in a second. But Vex, have you always been interested in low level systems? Like you mentioned x86, right? When did you get involved just like with learning x86 and going super low level on computing in general?
So it was, I wouldn't say that I've always been interested in it. Like I said, I did a lot of front end work for a while, so I've kind of hopped around the stack. But I got involved in some x86 work actually through one of my professors in my freshman year of college. And he had kind of just enlightened me on the glories of low level programming. And sometimes it's really ugly and sometimes it's really beautiful. But it's incredible what you can actually appreciate with higher level languages whenever you learn more low level languages. So like one of the biggest things that I'll always tell people when they ask if they should learn Huff is that like it's not like you'll use Huff to write every single one of your contracts, right? That would just be, you know, masochism. It would be terrible, right? But at the same time, like if you learn Huff, Yule is suddenly going to become easy. And if you learn Yule, Solidity is suddenly going to become easy. You can start to really appreciate the tech stack on which these higher level languages are built on. So you have like that classic idiom of like, you should learn Python, you should learn C++, you should learn C, and then you should learn assembly, right? And so when you're dealing with the Ethereum virtual machine, I would say that that stack is kind of like learning how to write raw bytecode, then learning how to write some language like Huff or ETK, then learning how to write Yule, and then learning how to write Solidity. And it doesn't necessarily need to be done in that order, but the amount of appreciation that you can get for some of the more higher level features that people have implemented with these languages from going to the low level is just incredible.
Yeah, so I like to say, for one, you know, I think it's almost as popular to you know, talk shit about the Solidity language. It's about as popular as talking shit about JavaScript, right? Like everybody loves to, you know, badmouth it, but I really gained a lot of respect for Solidity, like especially after learning Huff. I mean, even Yule, you know, like you said, there are still these higher level abstractions and you know, like basically higher level like control flow that you can take advantage of. But whenever you get in and you start using Huff or you start writing mnemonic bytecode, you know, you really start to appreciate like just how complicated jumping in a program is, right? Or even some of the unexpected behavior that you find in the EVM. I mean, very strange things that you wouldn't know about if you don't read the yellow paper or you don't try it yourself, right? So I agree. It's definitely like it's a great educational resource. And then, of course, you know, if you want just the most wildly optimized contracts out there, you know, you can definitely give that a go. on Huff, which actually I kind of want to pull a thread on what you mentioned earlier. So you mentioned that you wrote a SNARK verifier in Huff. Can you tell us a little bit about that? What scheme you're using, and what kind of, maybe if you've recorded this, what kind of differences and gas that you've seen with that?
Yeah, absolutely. So, just a preface, I'm by no means zero knowledge expert. But Andreas and I, Andreas from Rainbow, we attempted the Groth 16 malleability challenge from Geometry Research earlier this year. And I think that we spent probably about 5 or 6 days trying to do that challenge, and we just got absolutely stumped. And so that kind of spun off a thread of us really starting to like dive into ZK work, and we kind of started with snarks. And one thing that we noticed while we were diving into that is that the current snark verification contract was made a pretty long time ago, and it's the one that comes bundled with snark.js. And so we had like kind of just come off of the tail end of getting Huff RS to be stable, and we saw that there was kind of a hole that we could fill there with Huff, right? And so the Snark verification implementation is actually pretty interesting. Like we were able to do certain things like within the linear combination loop during the verification function, we have like two different addition functions, right? And the reason for that is that you have like a scalar multiplication result that's one side of an addition operator, and it's already stored in the 40 or 64 bytes of memory in scratch space. So there's no need to restore it, right? So as the number of public inputs grows, the RSNARK verifier actually becomes more efficient, right? So there are like certain patterns that we were able to implement in there that were able to beat it out. And I'm not sure the numbers off of the top of my head, but I think that it saves something around 8 to 9,000 gas per public input. To my knowledge, it's the most efficient Groth 16 SNARK verifier on chain, but I'm not 100% sure on that, so don't quote me.
Yeah, that's amazing, man. That's really, really cool. Actually, I actually used that verifier recently. Basically in a mobile app, I was trying to do, a snark verification, right? But it was in a mobile environment. So, you don't really have access to WASM. So you can't really like use those libraries like that. And so it was just very bare bones, just plug the inputs in, right? But basically, I put that snark verifier on Goerli, and then just, shipped it off to there. It was like for a small hackathon project. So it was really cool. It was very useful to be able to just pick that up and run with it, right?
Yeah, that's awesome to hear. I would actually love to see that app if you would send me that after the podcast. But yeah, another thing to note is it's unaudited, which is a big thing. So anybody that would like to use that in production, just keep that in mind.
Okay, so you mentioned actually a little bit earlier, writing every contract in Huff would be masochism, right? And obviously there are some massive gas savings you can gain from using Huff in specific use cases, right? I'd love to hear your thoughts, maybe Josh as well, as people who have really gone deep into Huff. What types of design patterns is Huff really good for? Like if I'm like a Solidity developer and maybe I see value in the level languages, but I'm like, is this really necessary for me to learn? Like, why would I go learn this? Like, where is it going to be most useful? How would you respond to that?
Yeah, I think that's like somewhat of a multifaceted question, and it really depends on how much you're willing to bear with, right? Like theoretically, you absolutely could go rewrite Uniswap v3 in Huff, or you could go rewrite Seaport in Huff. But there are a couple things to consider there. It's going to take you 5 times the amount of time. It's going to cost 5 times as much to audit. And then you're also just going to have to deal with all of the like foot guns that you can possibly implement. So like Yule, Huff has basically no overflow, underflow checks. Every single bit of security you have to implement yourself. Huff is kind of like writing glorified mnemonic bytecode. And we have a couple like syntactic sugar things. There's only really 1 or 2 high level features. So it's so unbelievably easy to create a contract that has a security vulnerability in it. Now, that being said, for certain things like very complicated math functions and modules that normally take up a whole shitload of gas, Huff can be a solution there. So we've seen a couple people show interest in using Huff for things like just deploying a simple ERC20 token that'll never need to be verified. I mean, never need to be updated again, or basically implementing their math libraries in Huff. Or even some people are talking about putting the Poseidon hash function, an implementation of that on chain in Huff. And for applications like that, I think that it's very useful. Now, that being said, there are a reason that high-level languages like Solidity and Viper exist. They're written by incredibly smart people. The optimizers do a great job at what they do, and they also have all of those security checks to prevent you from making those bad decisions or just basically making an insecure contract in general. So it's kind of a question of like, what are you willing to deal with? You know, ultimately, people could absolutely go and implement their entire protocols in Huff, like I was saying, but it would almost be unreasonable and also just like a time suck in both like development resources, auditing resources, and all of the above.
Gotcha. So yeah, it's a tool you can use for very hot paths, right? Like libraries that are used extremely often, like you said, complex math operations. I think that makes a lot of sense. One question that we asked a Viper god pretty recently is, so in Viper, you can't, and correct me if I'm wrong on this, guys, but I haven't written much Viper, but you can't break out an assembly box in the middle of Viper, right? In the mid, like a mid Viper contract, right? One thing we asked, Big Tech Sucks, right? You can go back and listen to that episode if you want. We asked him if the need to break out into assembly for specific things, is that a failure of the higher level language, right? That people decide to do that or want to do that? Or do you think that there will always be a need and a desire to use things like Huff? I have a feeling I know what you're going to say, right? Being a guy that contributes stuff and uses a lot of Huff, but I'd love your take on that.
Yeah, that's a really interesting question. And like also to preface this, like Charles is a professional and he probably has a better answer on this than I do, but the I think it depends on the design language of your like the design decisions that you make with your language. So Viper is very Pythonic and it seeks to accomplish all of the things in like pre-builds, right? So for that language, I think that based off of the decisions that they've made, they probably won't implement a lower level like assembly block, right? And basically, when you're talking about a language like Solidity, where you can drop down to a lower level language, I think that will always be at least somewhat necessary. However, I do think that technology can advance enough where you can get like the optimizer running at full speed and like basically just expanding on all of those modules to the point where lower level languages are less needed, right? So if you look at a language like Rust, for example, Rust you can write at a very, very high level. And then you can also go all the way down to embedded systems. You have unsafe Rust, and there are so many different categories of it. But at the end of the day, most people don't need to actually drop down to those lower level assembly blocks in a language like Rust. And I think that like languages like Solidity and Viper should absolutely approach to minimize the amount that people do need to use inline assembly. That being said, I absolutely love writing EVM assembly. It's a pretty simple VM, so it's not too much to get your head around. But that being said, I do think that in the future, it would be better if people didn't have to write as much inline assembly and have compilers be smart enough to actually deal with those problems for them.
I feel like a lot of people that work on low-level languages in the Ethereum space take a lot of inspiration from Rust. So I want to come back to that in a second. But can you just for our listeners, you mentioned like some differences between Yule and Huff a second ago, right? Do you mind just going through like what's different about Huff as compared to Yule and like why? I mean, you mentioned, you and Josh both mentioned that it's amazing as an educational tool, but I'd love to just like get a breakdown of why that might be, right? What are these things what are these extra things you have to understand or manage in order to use Huff? And why are there interesting performance improvements there?
Yeah, absolutely. And I would love to come back on the educational piece of Huff because I really think that that's where it's shining at the moment. But I think that the biggest high level difference of Yule and Huff is that in Huff, you have to manage the stack yourself. So the Yule compiler, the Yule to EVM bytecode compiler, will actually schedule the stack and manage pretty much everything in respect to that for you. In Huff, you're exposed to the raw stack and you actually have to do push, swap, dupe operations and all of that, right? In addition, Yule has this thing called the free memory pointer, which once you start writing Huff, you will find the free memory pointer incredibly useful, right? And on top of that, they have things like switch cases, they have for loops. And so Yule actually, even though it's a fairly low level language, has some really nice syntactic sugar added. With something like Huff, you implement all of those things yourself. So you're using jumps to move around for a loop, right? You are using jump tables to perform switch cases that are O to N, right? And those kind of things in Yule are a lot easier to manage. The other thing too is that Yule is functional. So like whenever you write like an mstore operation, you're writing like basically mstore offset value, right? Whereas in Huff, you're writing value offset mstore because it's acting as if you're kind of like talking to the stack directly. So things are almost like written in reverse, right? So there are some syntactic differences 100%, but I think also Yule has a couple high level features that are very, very helpful on top of some other things as well. But I think that like the biggest difference between them is the exposure of the stack.
One thing that I've been thinking about, as you've been talking, and as after a lot of conversations with Josh too, right? Because Josh, obviously is very deep into the Huff world. Would you say that like in order to actually really understand the EVM, it is like if you really want to understand it, right? Outside of like literally writing like ones and zeros bytes practically, is Huff the thing to learn?
So I don't want to shill my project too much. I think that there are also there are also wonderful other tools like ETK that come bundled with Geth and things like that. But I think that in this day and age, Huff is just an amazing educational tool in that regard. So for me personally, Huff filled the gap between Yule and the bytecode, right? And don't get me wrong, you should absolutely go write Viper. You should absolutely go write Solidity. You should absolutely learn Yule. But at the same time, having Huff in your toolkit will bring you to a point where you understand what's happening in that intermediate step between Yule and the bytecode, right? So being able to actually schedule the stack yourself. Most people are familiar with register machines, and that's what they get taught in their operating systems classes at school. The EVM is not a register machine, which fortunately makes it a lot simpler, but it's also something that a lot of people haven't been exposed to necessarily. So adding Huff to your development stack will bring you closer to the metal. That being said, it's not the only way to learn about the EVM. If you're more comfortable diving into the execution client and learning about those things, maybe that's a better way to learn for you. I think that it's subjective based off of who you are. I will say that for me individually and for a lot of other people that I've heard from, Huff has done that job of filling that gap to really understand what's happening as this code executes and being able to understand like, what the hell does this Foundry debugger telling me, right? All of those things put together, I think, make Huff a really, really valuable educational tool on top of potential production use cases. But I think that where we've really seen Huff shine as a language so far is teaching people more about what's happening as their code is running on the EVM.
Yeah, I do at kind of the one-liner for Huff, right? Is I like to call it basically bare metal EVM because it is very, very low level. And I think like earlier you asked like kind of what's the difference between Yule and Huff. Maybe a better comparison would be bytecode to Huff. Because if you look at the difference between what raw bytecode or mnemonic bytecode, which is basically bytecode, but in a human readable format, if you compare that to Huff, you really have, aside from ABI generation, utilities, really you have maybe two or three abstractions. One is jump aliases, which I think is Like if you've ever written mnemonic bytecode, you realize just how valuable that is. Because, if you have, let's say 5 jump destinations within your program, and, maybe you find an optimization later that removes a byte at the very top, every single one of those jump destinations become invalid. And the reason behind this is, in the EVM, you have an instruction or a byte that's called the jump destination. And if you want to jump to that place, you basically at some point push to the stack where that is in the bytecode, and then you jump to it. Right. And the idea here is just to make sure that, you actually know where you're jumping to. And that just becomes so painful when you're writing, complex things in mnemonic bytecode. Whereas, in Huff, this is abstracted away. You can give it a nice name and you can, jump to that, and at compile time, it figures it out. The others is macros. Macros and constants. Basically what these are doing, right, is duplicating this code at compile time. So if let's say you have a function, right, inside of your contract. If you call this function 3 times, the function only exists once in the bytecode, but it's jumped to 3 times, right, during its execution. Now, if you do this with a macro, what actually happens is it just puts that code, it regenerates that code 3 times in your bytecode. And so what this does, and kind of like the design choice here, was to minimize, jumps in your program, which is, slightly more gas efficient. So you can basically have these, aside from, things like function selector, switches, and basically figuring out which function to call. You can basically have a near perfect code path that doesn't jump at all, which, makes for very, very efficient contracts.
Yeah, absolutely. I think those are all wonderful points. One thing that I would like to add is that one of the only high-level features of Neo Huff, if you will, so kind of Huff after the Aztec port, is that Huff actually does have jump to and jump back from functions. So you can define what's called an FN, which is basically a function, and it will jump to and back from that function to prevent that code duplication. Personally, I haven't seen very many people using it because of the advantages of the macro design. However, they do exist. And the only reason that you'd ever really want to use that is if you're getting close to the spurious dragon contract size limit or anything like that. But that ability is there for the reasons that Joshua mentioned, is that it's really, really hard to implement something like that yourself. So if the compiler takes care of it and actually manages those jump destinations for you, it becomes much, much less annoying.
Yeah, that's really interesting. Are there any other design patterns or interesting optimizations you'd like to call out?
That's a hard one because there are so many, right? And like you have like those little like micro optimizations that people will do. So if those of you listening, if you've never read Vectorize's Soul Lady, it's absolutely amazing. He'll do things like store a function selector as like without shifting it, and then basically use the memory from the 28th byte onward so that he doesn't have to shift it left. Small things like that are really, really interesting to me. As for like some of the larger optimization schemes I've seen, like there are, gosh, it's so hard to just pick one, but like one that I've noticed a couple people are actually starting to use more now that the documentation is out are jump tables for function dispatching. So jump tables were added to Huff by the creator of the language, Zach Williamson. And basically what they allow you to do is perform like a 0 to n switch case in constant time, or I guess in EVM speak, you would say constant gas, right? So normally the way that people dispatch functions is that you will load the first 4 bytes of call data, and then you will compare that first 4 bytes of call data to a bunch of hard-coded values. So let's say you were calling a function that was like the 10th one that you compare. That means that every single time that you call that function, you're going to have to run through 9 jump I opcodes before that, comparing all of the functions before. And then finally, once you get to the one that matches, you'll jump into the contract's external logic, right? With jump tables, it's a little bit different. So you store the jump destinations to all of the logic within the runtime bytecode. And then what will actually happen is that it will index those jump destinations within the runtime bytecode and only use one single jump opcode. And so with that, you can actually, shave even like, 100 or 200 gas off of deeply nested function calls. And that's a really, really cool optimization that I've seen more people doing.
Yeah, I think that's probably one of the biggest ones, at the language level. And then of course, we have there's tons of little gas golfing things that you can do, within a program. Things such as using return data size before any external calls, right, to push a zero to the stack. Things I think Vex, I saw you do this one time where the very first instruction needed to push a zero to the stack, and you just called program counter. I was like, man, it's like I realize it's the first instruction, but man, that feels reckless, right?
Yeah, I do have to give credit to Salman and Natalie for that one. I did not come up with that one, so full credit to them.
Nice, yeah, that's killer. Which hopefully, maybe a little bit of alpha here. So we're actually out at DevCon right now, and there's going to be an EIP talk happening where basically we're going to discuss some potential changes to the EVM, like the actual execution environment. And one of those is actually going to be a push zero instruction. So right now, if you want to push a zero to the stack, which you have to do quite often, usually what you'll do is call the push one opcode, which this basically says you push a 1 byte value, and then right next to that you actually put the value 0, right? So OX00. The problem with this is, well, that's 2 bytes, right? And that doesn't seem like a lot, but as you start doing this over and over and over again, it adds up very quickly. So one of the hacks here was using return data size before an external call, which is going to be 0. And then there are other things like you can basically store that 0 on the stack, and as long as the stack doesn't go too deep, you can actually just duplicate that up to the top of the stack. All of that goes away with a push 0 opcode, which would basically it's a single byte, and it pushes a 0 to the stack, right? Now, I think this is really cool because, like I said, you don't have to do the duplication anymore, and then you also don't have to rely on hacks to do these small little gas golfing things, right? So I think that's going to be a really cool one.
Yeah, that would absolutely be amazing. Like I've seen a couple of the proposals. Like I saw that memory copy is coming back, and then a team is actually trying to push the mcopy opcode back through. We're seeing self-destruct maybe going away soon with, I forget the exact number of the EIP, but that's coming back into popularity. So it'll be interesting to see what they do with all of the DevX stuff over the next couple of years. I think that the one that most people really, really want is the moldiv opcode, but I don't think that I've seen too much activity around that one.
Can you walk through what the moldiv opcode is for our listeners?
Yeah. So basically, on Ethereum, you do fixed point math. So there's really not very many floating point numbers. There are floating point number libraries, but basically what moldiv will do is it will allow you to multiply two numbers together and then divide by a number afterwards. And so right now, the implementation that most people use is in T11 Soulmate, and that was written by Remco alongside T11. And that's already pretty efficient. However, having a single opcode for that operation that's done all of the time, right? So you're constantly converting between ERC20 decimal bases and things like that. Having a dedicated opcode for that operation, given how often it's actually executed, would just be absolutely amazing. So yeah, I think that the other thing that's pretty interesting about that is that there's two different implementations of it as well. There's like moldiv down, which is kind of like the default, and then moldiv up. So I wonder how they would actually handle that when it comes to an opcode. I would imagine that they would only do the one where it rounds down, but I've yet to see.
I think so. Correct me if I'm wrong, but you help maintain and contribute to Huff quite a bit, right? Am I correct in that assumption?
Yeah. So at least NeoHuff, right? So obviously it's built on the back of a bunch of people that did some great work before I came around. Zach Williamson made the language. Jet and Dylan kind of revived the TypeScript compiler, and then as of recently, since we've rewritten the compiler in Rust, I've done a lot of maintenance on it, and I'm still working on the project actively.
Nice. And as somebody that is really working on this and really cares about its future, what is your vision for the language?
That's an interesting question, right? So Huff, Huff is not like an official organization, right? Like nobody gets paid to work on it. Most people that contribute towards it do it out of the love for the language. A lot of people got nerd sniped, like Joshua and I, into helping out with all of the stuff. So I wouldn't say that it has like a super definitive roadmap. What I will say is that the people that do currently maintain it definitely care about it. It's an excellent tool for education, and so a lot of people are trying to push it on that front. Basically, yeah, I think that the educational piece is something that we're absolutely trying to push, just to make low-level EVM assembly not as scary, right? I think that a lot of people will look at a repository like Seaport or a repository like Soulmate or Soul Lady and just think that it's like black magic, right? But it really isn't. I mean, like the EVM is a fairly simple virtual machine. And so doing as much as we can to get more people really understanding the code that they write, in my opinion, just has such a positive network effect. And then in terms of the actual language itself, I think that there are a couple features that we really, really have been eyeing, such as adding a native bundled optimizer, which would be really cool, and kind of like actually showing the methodology of like why are we doing these optimizations to be able to explain it to the developer well. And then on top of that, the other feature that I'm really, really excited about, who one of the contributors that in the Discord has been working on, is stack assertions. So if you read any Huff code, almost the first thing that you'll see is that it's littered with comments. And rightfully so. I mean, it's mnemonic bytecode. You want to be able to explain to the reader what's happening. And the most prevalent comment is the one that's on the right side of every single line, which kind of details the layout of the stack. And so right now, whenever you're writing Huff, people will manually write those comments. And I myself have found sometimes that I have made an error in that stack comment trace, and it's affected my logic all the way down, right? And so being able to both automatically generate those stack comments and assert that they're true at compile time, I think is just it's going to be a game changer for the people that are actually writing Huff and trying to understand what went wrong when debugging. Because at the moment, like we've already got some really cool integrations. Like you can deploy your Huff contracts within a Foundry test suite and take full advantage of that amazing software. You can use the Forge debugger. I added the ability to write tests in Huff if you're crazy enough. Sometimes those are useful for just quick light checks and things like that. But when it really comes down to it, being able to assert that the stack comments that you've designated are correct, I think is a really, really big game changer in that regard. Like for instance, you'll see the takes and returns keywords next to macros and functions, and the only function type that actually enforces that are functions. So the ones that jump to and back from the code, right? Everything else, like it doesn't really, like the compiler doesn't really do much for you in that regard. Like, and that was the original design of Huff, is that it's so close to the metal that it doesn't need those kind of checks. And what we've been kind of deliberating on is like, how do we keep that characteristic of the language? We don't want to add more high level features, but how do we make it safer despite that design choice, right? So I think that those will probably be the next developments to see Huff. And from then on, I'm not really too sure. I think that we'll probably just keep hacking on it and use it. And like I personally use Huff all the time. It's like you just check to see what would happen if you do something, right? And maybe it's out of curiosity or what have you. But I think that hopefully it will become a decent part of an EVM developer's toolkit going forward.
Josh, do you have anything for the wish list? Anything on the wish list for the Huff ecosystem?
No, it's actually been so I've been pretty engaged with some of the discussions of features and things like that throughout, and I mean obviously like I think the last thing that I was really, really big about was the custom errors, and if I remember correctly, that's actually it's actually done now. But basically, what Solidity, I believe 0.8 started allowing were these custom errors where, not only could you define your own error types, but you could also actually pass arguments to those errors, right? And this is really good because before there were really two kinds of errors that you would see in the EVM. One would be panic, and that would come with a UINT 256 with a panic code. This is generally used for problems with arithmetic or I think there were some other very, very obscure like edge cases that you might come across. Don't remember off the top of my head, but those are what panic is used for, and then anything else is usually just a generic error that has a string. But the problem is strings take up a lot of memory space, especially once strings get above a certain length. It kind of gets out of hand really fast. So having these custom error types are great, and part of what Huff can do are these ABI generation utilities. So they're not actually, there's no enforcement at compile time of whether or not these actually exist. It's just a very easy way to write these human readable ABIs, right? And so we basically discussed adding custom errors in here where it would generate the error selector for you. And then whenever it's time to actually throw that error, you can go and deal with that directly. So that was definitely really, really cool. But I think that was the last one that I really made a big push for. I mean, beyond that, the language does seem to be fairly, I wouldn't want to call it complete, right? But I think there's not a ton more work, that needs to be done on the core, at least, aside from things like maintenance. One thing that I would like to kind of pull the thread on here a little bit is, Huff's place in MEV, right? Because there are, basically because there's so little checking and there's really just so much developer freedom there. I think there's a really big opportunity, for writing Huff in MEV environment. So, Vex, could you maybe kind of elaborate a little bit on some of the cool stuff that you might have seen or ideas that you might have for MEV related contracts?
Yeah. So we actually came across what appeared to be one of the first Huff contracts from like a high level searcher recently, and it was really interesting to see. So he had either written it in ETK or Huff or something like that. It didn't follow the regular Viper or Solidity standard that you would see in the bytecode. And so I think that where MEV searchers can really take advantage of something like Huff is that you're not necessarily writing your contracts for security like you would with a protocol, right? Obviously, if it houses funds, you need to make sure that those things are locked down, etc. But where Huff can really give you an advantage is that it can shave off a massive amount of gas from some of those more complex operations. Like if you are basically doing some sort of on-chain calculation within your contract, if you don't move that operation off-chain, if you're doing even liquidations or flash loans, being able to shave off that extra gas will help you to like win the priority gas auction sometimes. And so in addition, it'll also increase your profit margin, especially if you're doing, like hundreds of arbitrages per day, right? So there's absolutely a use case there. I think that it depends on the person, kind of like we were talking about earlier. It's all subjective. It's like how much time do you actually want to spend working on this? Do the benefits outweigh the cons, right? So in the MEV space, I think that specifically for contracts that just get hit all day by those like really, really popular bots and the ones that are landing most of the bundles, they could absolutely see an increased profit margin from using a language like Huff to write their contracts.
I love it. It's like an incentive for innovation, right? I think MEV's done that a little bit, right? It's like Formula One leads to a lot of R&D in cars. It's the same thing here, right? The other thing that you've been pretty involved in are capture the flags. What do you think the role of CTFs are in this space? Are they just an additional tool? Are they good for R&D? Like, what do you think?
Yeah, I think that they're good for a lot of things. I personally absolutely love capture the flags. Like every single time that I have the free time to participate in one, I participated in Joshua's earlier this year. I did Paradigm CTF and all of those. I think that the biggest thing for me is that it's always just a way to get exposed to something that maybe I haven't seen before, right? So you're doing things that you really wouldn't traditionally do when you're writing kind of like the happy path in your programs. So like for instance, there was this challenge, Merkle drop in Paradigm CTF 2022, and the vulnerability had actually shown up in Seaport, and I hadn't seen it. And so it was an option to learn about that vulnerability within Merkle trees. And it's just examples like that that really keep me engaged in the challenges. And then also, I think that it can push people to kind of perform these development sprints in which they'll just do like a lot of research on a very niche topic, just within 12 to 24 hours, right? And personally, that's a wonderful way to learn. I think that CTFs benefit the developer ecosystem on a very broad scale, right? Like the fact that Paradigm spends money to put on a Paradigm CTF every single year, it's amazing. I mean, that they put a lot of resources into that and creating that. And broadly, it's helped a lot of people learn to go back and actually say like, okay, like this had me ripping my hair out for 48 hours, right? And then to be able to see somebody else that had actually gotten through it and walk through their methodology. Because like one thing in Web3 is it's so interesting just how kind people are to share information, right? Like you'll have people writing these absolutely amazing write-ups on really complicated challenges. So like Plachi, who actually was the first person to solve the CTF that I just released, which finished this morning, he wrote this incredible article on solving this problem called JOP from Paradigm's 2021 CTF. And in that article, like seriously, I think that there's 6 or 7 just like gold mines of information, learning about how to use the Foundry debugger for certain things that you may have not thought of before, cheat codes that you may have not messed around in Foundry tests, etc. And just maybe even some approaches that you haven't taken before. So the other thing that's really interesting is that you'll see kind of like these CTF / optimization challenges, right? So 0x Beans released an optimization challenge like a month or two ago. And the problem wasn't intended to be exploited, but it used a pseudo random that if you submitted your transaction with a bundle, you could actually have the value of the pseudo random in order to kind of like completely bypass having to actually do the challenge, right? And like we just saw some absolutely insane code size reductions. People were coming up with just incredibly creative ways to get around that and to get their score down, because the score was bytecode size plus gas consumed. So a lower the score, the better, right? And with that, like just learning so many creative tricks from other people, it's almost like just complete real-time collaboration among some of like the best security experts in the Ethereum ecosystem. And so, yeah, I think that like over the next couple of years, I'd really, really like to see the CTF ecosystem grow, not only to attract other security experts from other spaces that might be interested in the growing CTF ecosystem on Ethereum, but to pull in already existing Ethereum developers and to just developing in a more security-minded way, and to really consider some of these foot guns that they've seen in the CTFs and apply them to their real-world work.
Take that to heart, kids. Do CTFs. CTFs are very valuable. Honestly, that's really interesting. I didn't think about, I guess being in Web3, you don't really realize, how open people are until you kind of go back and talk to people in different industries. I think you're absolutely right. Like the amount of educational material out there is incredible. And that's what we're trying to do with this podcast, right? Like some of the deep dives we've done today on Huff, I hope, someone who's interested in Huff will listen to this and be able to see this as a valuable resource, right? So totally second all those thoughts on CTFs. All right, we're getting toward the end of our hour here, but a couple of more general questions I might want to ask are around just like your thoughts on the ecosystem, what else is interesting, and your long-term vision for the space. Like you said, you're young, you're a senior in college, right? So you'll have a long time in this industry, hopefully. Let's say right now I told you couldn't work on Huff or anything Huff related, right, for the next 6 months. I'd love to understand what else you're interested in, right? What things maybe you would work on if you had that open time. Do you have any thoughts there?
Yeah, absolutely. It's kind of a hard one because there are so many. Like there are so many like really, really cool kind of niches in our ecosystem. You can go into the ZK space, you can do client work, you can start working on scaling, which might coincide with client work and the ZK space. There's obviously MEV, there's dev tooling, pretty much all of those things really, really interest me. And I'd say like, if I couldn't write any Huff for the next 6 months, I would most certainly be trying to write more Rust. I cannot wait to graduate because I have a limited amount of time that I can actually work on this stuff. And I'm really glad that I actually just found a job in the ecosystem, which I haven't been able to announce yet, but I'm really excited about being able to continue working in this space. But I would say that like if I had to choose two, because I don't think I could choose one, it would probably be working on more dev tooling. So contributing towards things like Foundry and Heimdall and some of these just amazing tools that people have been making this past year just to make Solidity development so much easier. Like I started with Ganache and Truffle, and like using Foundry in comparison to Ganache and Truffle is like a world of a difference. It's improved the feel of writing smart contracts like 100-fold. So I think that those are like very, very high leverage projects. And then on top of that, like one thing that I've really, really wanted to do over the past year that I just haven't had the time to do is like really dive into like learning more about like execution clients and figuring out how I could contribute more to the actual Ethereum network rather than just dev tooling and protocols, right? So I would say that those are kind of the top two. And then if I had to choose like a 3 and 4, it would definitely be just diving more into the ZK space. Like I've been taking some math classes on the side just to try to figure that out and try to get more familiar with it. It's definitely some moon math in certain areas, but I'm definitely getting there. And alongside like kind of working with the ZK space, like building on top of the ZK space is also very interesting to me. So we were thinking about just so many different applications that you could make, like a zero knowledge job site to where you could post your salaries and have like nobody actually know who you are and kind of like protect you from your employer in that sense. And like just all of these different things that you can build in that realm is just incredible. You have Aztec just having released Noir, which makes ZK development so much easier. I think that there was and then also you have Circom developing, and Circom has evolved so much since it came out. And so, yeah, I mean, I wish that I had 100 hours per week to put towards this stuff, but those would definitely be, I think, my top 3 or 4.
I love it. Well, congrats on getting the job, and I hope you do have some time to contribute to the broader ecosystem because I think you have a lot to offer. Final question, right? This is far more general, but let's zoom out a bit, right? And let's imagine we're 10 years in the future. It's 2032. You'll be like in your early 30s, right? So you'll still be pretty young. What do you hope our space looks like at that time, right? If we step back, what do you hope crypto and Web3 does for society?
That is definitely a very broad question. I would say that like one of the biggest things that I would really, really, really like to see is more privacy by default. Right now, I think that people are developing towards that, and it's an incredibly interesting space, kind of branching off of the whole ZK idea. But like one of my big worries is that blockchains will like all of the effort that's being put towards blockchains will eventually be seized by a malicious party. And so having privacy by default will absolutely assist against that. And then on top of that, I think that blockchains have a lot more to offer to the world than just financial applications, right? Like being able to have a distributed network with provable computation where you can store pretty much any information. And we're going to have all of this, like Ethereum is about to implement sharding. We're about to have like the surge and all of that stuff. And then on top of that, you have this insanely intricate ZK EVM space popping up. So we're going to have all of these different layers, layer 2s, 3s, and 4s. You never even know how high that's going to go, right? So being able to actually move a lot of the internet's data into both a privacy by default distributed information ledger is just one of the most just as like pleasing ideas that I could possibly think of, right? Is like you look into all of the problems with like data ownership and companies like Google and Meta and all of their counterparts basically just owning every piece of data that we create on the internet, which is properly ours. And they make an incredible profit off of it. And so being able to actually give that ownership back to the people, and on top of that, create somewhere where people feel safe for sharing their information when they feel like it. So, I mean, people have brought up some just absolutely incredible ideas like moving healthcare data into a zero knowledge proof application and actually having kind of like real ownership over not only financial assets, but data. I would say that I absolutely am interested in the decentralized finance aspect of what blockchains can bring to the world. And I think that there are incredible minds working on that problem. But I think that what I've been far more interested in recently is thinking about the blockchain more so as a distributed information ledger rather than only being something that can cure the current global financial system problems, right? And I absolutely do think that it can do that. But what I think that I'm looking forward to the most is seeing basically the whole problem of data being owned by these mega corporations solved. And I think that under the right hands, blockchains absolutely have the power to play a very big part in the solution to that problem. I think that it may be multifaceted and that blockchains may not necessarily be the only solution, but as of the technology that currently exists, and all of us know that in 10 years it's going to be an unrecognizable landscape, blockchains absolutely look like a good contender towards actually moving towards solving that problem.
It's inspiring stuff, man. That's a fantastic answer. Well, listen, we really appreciate having you on today. Before we hop off, where can people find you online and all your work?
Yeah. So I'm Vex_0x on Twitter. And then you can probably find my GitHub and everything on that throughout my Twitter. I'm not super active on Twitter because I'm not a huge fan of social media, but I try to post cool things every now and again. You'll probably find best on my GitHub, which is Clabby, CLABBY.
Vex on Twitter, Clabby on GitHub. Awesome. Well, listen, we appreciate all the good work you're doing for the space. Glad we have young guns like you and high school age kids younger than you out here building the future for us. I'm really excited for it. So thank you again for coming on.
Yeah. Thank you guys so much for having me. And then like I've looked up to a lot of people in this space, and Joshua is somebody that I've read all of his code before I even met him. And it's been great to be able to have a lot of wonderful mentors and people to bounce ideas off of as well. So thank you guys for having me on, and it was awesome to be able to meet you.